The ultracool star Trappist-1, located about 40 light-years from Earth, hosts at least 7 exoplanets, most likely rocky worlds the size of Earth and smaller. This star boasts not only the largest number of Earth-like worlds in a single system known to date, but also the most planets that could host liquid water on their surfaces. Main story: major discovery. 7 Earth-size alien planets circle nearby star. Images: the 7 Earth-sized planets of Trappist-1 in pictures. Full coverage videos of the 7 planets in Trappist-1. 3 lie within the habitable zone, the region around a star where liquid water could form on a planet's surface, making them excellent contenders for the evolution of life. 1 world lies farther out, and is likely icy, while the 3 closest to this star are heated by its temperatures. Diagram of the orbits of the Trappist-1 worlds, compared to those of Jupiter's Galilean moons, Mercury, Venus and Earth. Credit SOO. Verdict. In 2010, Michael Gillen, an astronomer at the University of Liege in Belgium, and his colleagues began monitoring the Sun's smallest neighbors using the Transiting Planets and Planetesimals small telescope TRAPPIST in Chile. They looked for so-called transits, when the light from the star is dimmed by a planet passing between it and Earth. Because low-mass stars are dimmer than their Sun-like siblings, it's easier for astronomers to spot planets around them. When Gillen and his colleagues turned their telescope to the star now known as Trappist-1, they found that it faded at regular intervals. In 2016, the team announced the presence of 3 Earth-like worlds around the star. These planets orbited their star every 1.5, 2.4 and 4 Earth days, respectively, making them between 20 and 100 times closer to their star than Earth is to the Sun. Although the star produces nearly 1,000 times less radiation than the Sun, the worlds are most likely still too hot to hold a significant amount of liquid water at the surface, although some could be present, the researchers said. The finding encouraged Gillen and his team to keep investigating. They continued to study the intriguing star with the European Southern Observatory's ESO ground-based TRAPPIST and the Very Large Telescope VLT in Chile, as well as NASA's Spitzer Space Telescope and other instruments. In February 2017, the team announced the discovery of 4 more planets. The worlds are currently known as Trappist-1 b, c, d, e, f, g and h, moving in order outward from the star. The observations, published in the journal Nature, revealed that all 7 are terrestrial planets. This is an amazing planetary system, not only because we have found so many planets, but because they are all surprisingly similar in size to the Earth, Gillen said in a statement. Characteristics of the 7 Trappist-1 worlds, compared to the rocky planets in our solar system. Credit NASA's Occultech. Trappist-1 is about 40 light-years from Earth. It lies in the constellation Aquarius, but it is too dim to be seen by the naked eye or even visually with large amateur telescopes, according to the ESO. It is only about 8% the size of the Sun, and it's much cooler, redder and dimmer. All 7 worlds have orbits that would fit inside of Mercury's, but they experience much cooler temperatures. Trappist-1 C, D and F receive approximately the same amount of energy as Venus, Earth and Mars, respectively. Each of these 3 rocky worlds could potentially harbor liquid water on its surface, a key ingredient for life as we know it. Looking for life elsewhere, this system is probably our best bet as of today, said Brice-Olivier Demery, a researcher at the University of Bern in Switzerland and an author on the most recent paper. In the coming years, telescopes such as NASA's James Webb Space Telescope, scheduled to launch in 2018, have the potential to detect the atmospheres and temperatures of these recently discovered worlds, thus helping scientists better understand how welcoming they might be for life. With a star roughly 80 times as large as Jupiter, the Trappist-1 system bears a strong resemblance to the massive gas giant and its 4 Galilean moons, Io, Europa, Ganymede and Callisto. The moons take between 1.7 and 17 days to orbit Jupiter. Both systems have an orbital configuration in which the orbits of the planets are connected. When Trappist-1 b travels around its Sun 8 times, the next 3 orbit 5, 3 and 2 times. This resemblance suggests that the Trappist-1 planets and the Galilean moons formed and evolved in a similar way. Ignace Snellen, a professor of astronomy at the University of Leiden in the Netherlands, wrote in an article in the journal Nature. That could have intriguing implications for the 7th satellite, Trappist-1H, which is too far away to keep water in liquid form by relying only on its Sun. The gravitational pull of Jupiter and the other moons is thought to be responsible for maintaining a liquid ocean on Europa, despite the lack of solar heating. Io, Ganymede and Callisto are also suspected of hiding water beneath their crusts by the same means. The TRAPPIST-1 system could hold 4 potentially habitable planets instead of 3. Gallery: the 7 Earth-size planets of TRAPPIST-1 in pictures. TRAPPIST-1 also has strong implications for the abundance of Earth-like planets in the universe. The transit method used by the team only works if the planets and the Sun line up. According to Snellen, that means anywhere from 20 to 100 times as many planets remain unseen, hidden because they don't cross between the two stars. Finding 7 transiting Earth-size planets in such a small sample suggests that the solar system, with its 4 sub-Earth-size planets, might be nothing out of the ordinary, Snellen said. Gillen and his team will widen their search with the Search for Habitable Planets Eclipsing Ultracool Stars project, which will use 4 ground-based telescopes to study 10 times as many faint stars. And in March 2018, NASA plans to launch the Transiting Exoplanet Survey satellite, which will spend 2 years hunting for planets around some of the brightest stars in the sky, though none as dim as TRAPPIST-1. Ultimately, scientists say these 7 newly identified Earth-size worlds offer the best bet yet for finding life outside our solar system. Why are we trying to detect Earth-like planets around the smallest and coolest stars in the solar neighborhood? The reason is simple. Systems around these tiny stars are the only places where we can detect life on an Earth-size exoplanet with our current technology, Gillen said in 2016. So if we want to find life elsewhere in the universe, this is where we should start to look. Additional resources: TRAPPIST-1 website, Trappist Telescope Network, ESO Trappist website.